Hello and welcome back to the thrilling conclusion of our Max for Life device building extravaganza. My name is Michael Creek and we are going to pick up right where we left off, and that is having a call object that has all the different modes of arpeggiation saved in it and being able already to find all the devices and all those devices parameters inside of our selected track. Now, we have two little problems. One is, I would like to have this message box here appear in our presentation whenever there is actually an arpeggiator style selected, and have it disappear when there is no arpeggiator style selected. And also there is a specific problem with some of those modes, as you can see here. All the modes that consist of only one word have symbol in front of them, which is because those longer ones, Max automatically finds out that those are actually a string of symbols, whereas in the single ones, it could also be something specific to the Max language. For example, if I wrote bang in there, then it would send out a bang instead of setting the string bang. And if I wanted to have the string that is just called bang, I would have to write symbol bang. So Max puts symbol in front of it so it doesn't get confused or something. I'm not entirely sure. But we just want to cut it off. But luckily, this is really easy because we've already had this zl.filter object. Just set it to symbol. Put it there. Cut it off. And we're golden. Nice. So now to the slightly more interesting problem. We've already attached a select style object here. So our Max for Life device will know when there is an arpeggiator style selected. Now what we want is when a style is selected, there's going to be a bang out here. And when there is no style, there's going to be a message sent out here. So let us just swiftly convert this message into a bang as well by using a button, which you can create by hitting B, as we already know. And now there is just one thing we have to set with this object. To do it, go to the Object Inspector and look under Appearance. You can see we have it not included in our presentation right now. We are going to change that. We will have to set the presentation rectangle in the patcher itself, which just means dragging it to somewhere where it's inside of our boundaries of the device. And now also, we can select Hide on Lock. And this is what your inspector usually looks like. There is not this extra column on the left side, but it's very helpful. It's this one. It's called Show Attribute Name, and it just shows you what is the name for this attribute inside of Max. And this is all this in this left column is what you can send as a message into the object and have it interact. So Hide on Lock in Max speak is called hidden. So right now, when you go to presentation mode and move this thing to where you want it to be, I'm just going to put it over the other message box because we don't need it then. Now, if I lock this patcher, it's going to disappear. And this is what we want it to be like as long as there is no style of arpeggiation selected. But if we do select style of arpeggiation, we want it to not be hidden anymore. So what we do is we send a message box, call it hidden $1, send it to the left inlet of the message box. And now what we do is when style is selected, we want a 0 to be sent into that. So it's going to be hidden 0, which means it's actually visible. And when something else than style is selected, we're going to have a 1 sent in there. So one thing you want to do is whenever you send a very important message into an object, you usually want to make sure that this is actually sent, because before you hit this thing here, it's not going to be active. So what you do in Max for Life devices is you use the object live.thisDevice. Live.thisDevice is going to send a bang as soon as this whole device has finished loading. Okay, so now try it once again. This is where we're at. Take the arpeggiator, select style. Ah, yes, and it works. Perfect. Select something else. And instead, what is this? Transpose steps. Instead, we see the actual value. There is one big problem that can occur that we haven't yet looked at. And this problem is called creating a rack. Now, I build a rack. I hit our device checker to find all parameters, and you're going to see it sees the device checker, it sees a MIDI effect rack, and it sees the synthesizer. And if I select the MIDI effect rack, it can only find the 8 macros, our chain selector, and if the device is on or off. And that is actually a big problem, because we built this whole device for the sole purpose that in this situation, we would be able to still track the arpeggiator without it having to be visible. Now, in order to get this cleared up, we would usually need something called recursion. Let me show you real quick what I mean with recursion. Recursion in a nutshell. Congratulations, you finally did it. You've built your own robot. And you want to make your robot the most polite robot that anybody could imagine. So you wanted to basically go around, say hello to everybody, and then say goodbye to everybody before leaving. Because, you know, that's kind of what sensible people do. So, how would you do that? You would probably give your robot a set of instructions or rules that would dictate how he's acting. So, another word for those instructions would be an algorithm by which the robot operates, or a function. I refer to these names because function is the word of choice in a lot of programming languages for what we are about to witness. Let's give it a set of rules. First of all, what the robot is supposed to do is it's just gonna say hi. Now that our robot has introduced himself, he's free to go somewhere else and maybe meet other people. So, let's ask the robot to look for a door that leads to another room. If you find a door, go in there. Of course, because you go there, you want to do the whole stuff all over again. Now you've said already hello, you also need to say goodbye before you leave for good. And this would be a valid set of rules for a robot to be very polite by. What I'm referring to with this arrow is not something like a loop. It's not you do the 1, you do the 2, then you go back, you do the 1, you do the 2, you go back, and then at some point maybe you go to the 3 or something. What I'm referring to is actually when you go somewhere, you take this whole thing and start it all over again. And that's basically recursion, because what recursion means is you have a function, and this function is able to trigger itself. So, because this sounds kind of weird and confusing, let's give this a shot in real life. So, our robot enters the first door. Wait, that's not what doors look like. This is what an open door might look like. So we are in a big giant room and we go in there. So the robot is gonna say, hi. Second of all, it's gonna look for a door. And just looky there, there's another door in there. Now, because we found a door, we're gonna go there. And we are gonna start this function again, without stopping this function going on over here. It's just waiting for now. So now we're in a new room. Our robot is gonna say hi. And it's gonna look for yet another door. It's gonna go in there. Gonna say hi. And it's gonna look for doors, but there are no doors. So it can go to bullet point 3, which is say bye. And then it's going to go back here, because this function has not yet stopped. And we've already said hi here. We've already looked for other doors in here. We've already been there. So it's time to say goodbye. And we're going to go back. And as you might have guessed, we're going to say bye. And that's recursion in a nutshell. It is a function that can recur in itself. And this can be very handy in a lot of programming environments. For example, in what we are about to experience, when you start the loop, we don't know if there's going to be 3 substructures of recs or maybe 4 substructures of recs. We don't know how deep this rabbit hole goes. And by having a recursive function, it's kind of irrelevant because it's just going to keep going and going until it's done. And that's recursion in a nutshell. Ableton works in a way that you can create a MIDI effect rack, but then in this MIDI effect rack, you can create another MIDI effect rack. And then in this MIDI effect rack, you can create even more MIDI effect racks. And the problem that we're getting is that the Ableton API gives every device a parameter that is called can have chains. And that means, is this device an effect rack, and does it have these different chains? And in these chains, could there be more devices? And this attribute either says nope, or it says yes. And what we want to do is, whenever we check a device and we find out that it can have chains, then we want to check out those chains for more devices. But then we are checking more devices, but we also need to check, can this thing in turn have more chains? Because yes, actually it can. So this is kind of where recursion would be very useful. But Max is not really designed for recursive functions. As far as I know, I've been to the Cycling74 forums. They said, oh, it's really no problem. Just install this external object that allows you to program in the Lisp language. And then, you just do your recursive loops in Lisp. Yeah, okay. I'm sorry, I'm not a real programmer. I don't speak Lisp. So what we are going to do is we're going to do pseudo recursion. And pseudo recursion is going to work something like this. There is an object which is called zl.stack. zl.stack is considered a LIFO thingy. And LIFO means last in, first out. So what you do with stack is you send items into it, and then whenever you bang the stack, then the last item that has been put in is going to be put out. And also, there is here a number of items that still remain in the stack. So it's kind of like your daily mail. Ugh. And what we're going to do is we're going to check every device that we get here. We're going to test it for if it can have chains. And then if it has chains, we are going to take these chains and add them to the stack. So those chains in turn are going to be searched if they can have even more chains. And if they do, they are going to be sent right into the stack. And then we're going to just keep working the stack until there is no more objects waiting in the stack to be processed. And then we send the whole list on to this all thingy. So what we do is we take a break right here at get all device IDs, and we're going to check these devices. And we do this by first extracting the ID, because we're going to need this later. And then we're going to send this thing in the stack. And the stack works in a way that if it doesn't get banged, nothing is put out. So what we want to do is we want to send the whole list into the stack, and then we want to start the process of working through the stack. So we're going to do a trigger bang list, which means, first of all, we send the list in there because, Max works from right to left. And then we're going to send a bang in there. Also, we can already create an emergency bang because there's gonna be more bangs to be had. Now, what happens? We remove the ID, so all that remains is the numbers of the IDs that are devices in our track. We put them all in the stack, and then we output the first one here. What are we going to do with that? First of all, we are going to send a trigger, a bang, and an integer, because now it's not a list, but only a single thing. So first of all, we send the integer. We prepend ID again, because now we need the ID. And then we send a message that is called get can have chains. And this is what we're going to send the bang into. Okay. Now we need to have a live.object that is actually listening, and we're going to give the ID to this live.object. And then we're going to send this in here. So what's going to happen is we put out the first number, say 15. There's going to be an ID in front of that. We have this live.object listen to the device that we have selected first. And then we ask it, can you have chains? And what is going to be output here is can have chains either 1 or 0. Well, let's check this out. Just hang a message here. Get all devices. And you can see the first device we have can have chains 0, so it cannot have. We only need the 0 or the 1, so what we're going to do is we're going to filter out the first bit, which we can do in a lot of different ways, but I like to do the zl.slice1, which is going to cut off the first element of the list. It's going to be output here, we don't need this, and then have the second, well, the rest of the list, which is only the number in this case in the right output. So we bang this, 0, nice. What do we want to do when this happens? We select the 1. Select 1 means if it can have chains, then here is going to be a bang. And if it cannot have chains, then the 0 is going to be output here. But I think we're going to convert it into a bang. Now, when there is no possibility for it to have chains, then we don't need to check it further. All we need to do is check the next item in the stack. And actually, there is a button already, so we don't need this. Just do it like this, hit Command-I, make it look a little less ugly. But wait, we have forgotten one thing. Now we are checking through the stack, but all the while we are doing this, we also want to collect all the IDs so we can, in the end, send them all here. So another nice object for this is called zl.group. zl.group is gonna take any kind of items and combine them into a group, and it's not gonna send them anywhere until you bang it. So actually every device that is checked is also a device that we later want to have here. So as soon as we have prepended ID again, we can just send the whole thing into our ZL group. Yes. So now what happens? We send something in here, we find out it has no chains, it's already added to our group that is going to be sent out in the end. Then we bang the next one. So the next item from the stack comes out. Just imagine it can have chains. What happens when it can have chains? When it can have chains, we want to find out if there are chains and what devices are in them. So then what we need to do is we just get all the device IDs. So there's going to be a bang when it can have chains. We then check it for all device IDs, which is going to be a whole list of IDs. And then we are going to zl.filter out the IDs because those are just messy. And then this filtered list is gonna go into the stack. And also, we need to bang once again, so the next one gets sent. So we also, no, wait, we do it in a different way. We do it like trigger bang list. It's a bit cleaner, I think. Yeah. Oh my god, it looks so horrible. So first of all, we send the list in the stack, and then we bang the stack, so the next one gets checked. And this can keep happening until we have run out of stack. And once we've done that, there is gonna be a 0 here, because the number of items left in the stack is always output whenever you bang the stack. So all we need to do is we need to select 0, because that's when the stack is empty. And then we need to do one little trick, which is defer low. Defer low messes with the priority of Max processing data, because usually the ZL stack would first send out a 0 here, and this would cause us to end the whole cycle before the last item has been processed. So what we want to do is we defer the message. So in this case, the stack finds out that there is nothing remaining in the stack, but then here, the message kind of gets delayed until this whole thing is processed. And then, when we are done, we are going to bang the whole group. And there's going to be a big ol' list of IDs. And those IDs can then be sent here and here. And if I haven't made any big mistake, then we should be fine. Turns out I've actually made a mistake, because you can't just get the chains like this. When an object has chains, then because it's kind of a little princess, this life.object, you need to kindly ask it where its chains are. So what we do is we send the same ID that is currently being checked into another live object, and then when there is actually the possibility for it to have chains, we need to send a message in here that kindly asks the live object, could you please, oh my god, what am I doing here? Could you please send us your chains? And then all those chains are going to be output, and then we can get all the device IDs of those chains. One last thing to tweak is we want to once again get rid of something we don't need, because when you ask the live.object about the chains, it's going to, just like here, send out chains and then the list of IDs. So we need to filter out the chains. You can do it either like this, or maybe it's more intelligent to do it like this, slice off the first bit, but then send the rest into this. Now we bang this thing, and oh, this looks kind of messy. Let's check this out. We bang this thing. We have the analog MIDI effect track, scale, arpeggiator, random MIDI effect track, pitch, and device checker. So you can see now, because of the last in, first out nature of this thing, it's going to have everything from right appearing to left. So you know that this is the innermost MIDI effect rack, and this is all the instruments in there. And then this is the more outermost effect rack with the messages in there. Now, if we switched this up, if we didn't use the last in, first out, but the first in, first out, this would be zl.q. We would have, like, this is the outermost layer, this is the device checker, the effect rack, and the analog. And then it goes deeper into the MIDI effect rack inside of the MIDI effect rack, and then have random arpeggiator and scale that are tightly in there. And then pitch, which is where? I think it's inside of this device rack. Yeah, it's inside of this device rack. So with this kind of ZL object, you have it like the most superficial things here, and the deeper you go into your racks, the further down you go there. I think I actually prefer this to stack, so never mind the stack. Here come the ZL.Q, which is going to be FIFO. All right. And there you have it. There you have a little Max device that can check your different parameters. The last thing that would make sense is making everything look not quite as horrible. So for example, everything in here, with the exception of MIDI in and MIDI out, everything in here is just an algorithm dedicated to kind of doing the pseudo recursion. So you hit up Command-Shift-E, you got it nice and encapsulated. I actually call this pseudo recursion because it's actually not recursion at all. But still, you know, doesn't this look a whole lot better already? Then you got this. I think that's okay to leave it like that. That's okay. Now here you got the lookup object that checks your current status, as well as this. No, I think we can actually leave this separately. So this is another thing that we could encapsulate and maybe just call it param checker or something. So this doesn't look quite as horrible now. And then whatever we have here with the call and the select style and the hidden, we can encapsulate all of this. And this is going to be our patch checker. So you got it like that. This looks all right. This could be a little bit less messy. Come on. And there you have it. A very simple piece of Max for Live data processing. Fits into a little box here. Maybe we can even make it a bit less space consuming. And that's our device checker. Have fun with it, everybody. And see you next up when we are actually going to create interesting MIDI effect tracks. Bye bye.